The question 5, everybody got kind of a different question. It's pulling from like 6 or 7 different questions. So you might have got a completely different question in your name. So I'll do a couple of these. It says, test the statement to see if it is reversible. If so, write as if true by condition. So we take this statement, we want to write this statement as an if-then statement. Okay? And then we're going to come up with its converse. And the converse is basically the reversing idea, right? Okay? And we're going to see if both of those are true. If they're both true, then we choose the one that is providing us the biconditional. Okay? Looking at A, B, and C, hopefully you recognize that the one that's the biconditional is the one that says if and only if, right? Okay? Ultimately, this thing here doesn't really do anything for us. Okay? So we're either going to choose A or B in this situation. But to write this in a if-then statement, it says 2 angles that have the same measure are congruent. Okay? Think about how you could, we're talking about 2 angles, right? So that's my subject. And the feature of them is that they're going to have the same measurement. If they have the same measurement, then they're going to be what? Congruent. Okay? So we can kind of verbalize that and put that into a good if-then statement. We would say if 2 angles have the same measure, then they are congruent. Okay? What I want you to do when you write that statement, think about, does it encapsulate everything the given statement provided? Okay? We want to make sure we don't alter what this thing here is saying. Okay? And I think it does that. Next thing we want to do is say, is that true or false? That'd be true, right?
Yeah.
I don't know where I went there. Be true. Okay? The next thing we want to do is see, is it reversible? And we can always reverse it. But does that reversing create a true statement? That's the question we're asking. So I'm gonna come up with a converse. It says if 2 angles are congruent, then they have the same measure, right? Would you agree that that is a true statement? That is a true statement. Okay? So if that's a true statement, can't we write that as a biconditional? Both goes together. And the biconditional being this one, and if you look at this, it says 2 angles have the same measure. 2 angles have the same measure. Take the word then out, put the phrase if and only if then, okay? And then they finish off, the angles are congruent, okay? Or they are congruent. All right, so we would say option A is, all right? Something, I think when people miss this, they've maybe got a question that was maybe like this one. Okay, this is, I think, a little bit harder for people to think about. Okay, linear pairs are adjacent. Okay, it says 2 angles that form a linear pair are adjacent. So I'm going to write that as if 2 angles form a linear pair, then they're adjacent, right? Would you guys agree with that? Remember, a linear pair means they're going to form that straight line, and they're going to act 180 degrees, and in order to do that, by definition, they have to be adjacent, okay? If I flip that around, if 2 angles are adjacent, then they form a linear pair. What do you say about that? That is false. Okay? Are these 2 angles there? If that's angle 1 and that's angle 2, are they adjacent? Yes. Okay. If 2 angles are adjacent, so we say that that's true. But do I get a conclusion that they're a linear pair? No. So that's why it's false. With a true hypothesis, we can find a counterexample that makes the conclusion false, and that's why I would say, in this case, the statement is not reversible. Okay. This one people struggle with, I think, as well. Parallel lines. We haven't talked a whole lot about parallel lines, but we did mention this at one point earlier, maybe the second week of school, first week of school. It says 2 parallel lines do not intersect. Okay. So writing that, we say if 2 lines are parallel, then they do not intersect. My fingers are like freezing, so that's why my typing sucks. Huh? Interact? There you go. That's not right either. There you go. Would that be true or false? That'd be true, right? Okay. If two lines are parallel, then they do not intersect. Now, if I say if two lines do not intersect, then they are parallel. That is a false statement. Why? I think I'm hearing some of the right arguments, okay, but when we say just two lines, are we saying whether they have to be both in two dimensions?
No.
No, okay. So if I have any two lines that are in one dimension, as long as they're, something like that and something like that, those are my two lines, right? Okay. Now going back to the phrase that we had, if two lines do not intersect, then they are parallel. In this case, if I can get those two things, if I can get those two lines to position themselves so they do not intersect. So what was you guys remember from algebra, what's the property of lines so they do not intersect? They have to have the same one. Same slope, good. Okay, so I'm going to force this one to have a slope down 1 over 3. So down 1 over 3 again would be that one. Okay, and we're going to see no matter how far I zoom out, those two lines will not intersect, right? Okay, so the idea was if two lines do not intersect, then they are parallel. Would you agree? Those do not intersect, thus they are parallel.
Yeah.
Okay, now here's the issue. They do not say anything here about whether this has to occur in two dimensions. We could be looking in 3 dimensions. Come on, there we go. And let me just delete this out. Didn't want that. Would you agree in 3 dimensions that those two lines do not intersect? Yeah, but we don't consider those types of lines parallel. You guys remember what we called those the other day? About 2-3 weeks ago? Start with an S. Skew. Okay, you guys remember hearing that word? Okay, those lines are skew, not parallel. Okay, so that's why if you answer this question as a lot of people probably answered that as true and then said the biconditional was what we could say. Okay, it should actually be false, and we would say the statement is not reversible because of that idea of parallel and skew. And that's, I know we haven't talked a whole lot about that, and that we haven't defined it. We will in the next chapter. But as you go through this course, we're going to ask questions like this all the time. So it's very important for us as we learn vocabulary words to not just learn them for 2, 3, 4 days, but to learn them and then retain them, and they become second nature to us. These were question 10, and I think there might have been some notation here that maybe confuse some people. They just give you 4 phrases here, right?
Yeah.
Okay. Don't really care what those phrases right now say, but they tell us, it says substitute for P, Q, R, or S, and write the statement the way you would read it. Okay. If you go to our PowerPoint, it says it in the PowerPoint, in the videos, if you watch those, the class that I recorded, this was in that video as well. Whenever I have S, arrow P, okay, that arrow is starting at S and going straight to P, right? So if I'm traveling down that arrow, I can only go that direction, okay? I can't start at P and go to S. What S is just some generic hypothesis. What P is just some generic conclusion. Does that make sense? So if S up here is this phrase right here, and P is that phrase right there, what I'm going to look at, I'm going to read this as if angle A and angle B are adjacent supplementary angles, then angle A and angle B are a linear pair. Okay? So we go through here, we're trying to figure out which one of those they're talking about. Okay? Obviously, because this arrow is only a one-way street, we can't use that one because it says if and only if. We can't use that one because it's if and only if. And that arrow means if, then. Does that make sense?
Yeah.
Okay. So then we figure out which one it is. It's got to be adjacent supplementary, so it's option B. Okay. C is actually the converse of that statement. Okay. So we're looking for option B here. My smartboard's been kind of messy today. It doesn't like the... Like when I try to write on it, it's fine, but when I try to click these things, it's like 7 inches off. This one here is a little bit different. Look at the arrows here. Different, right? Now the arrows, I can travel from P to S, but I can also travel from S to P, right? Okay? So what this incorporates, this is two ideas here. This is P, go to S, but you can also start at S and go to P. Okay? Well, if I come up with those, that's an if-then. If P, then S. And this is an if S, then P. And if those two things are both true, can't we rewrite that as P, if and only if S? Does that make sense to everybody? Okay. So P and S here, P is angle A and B are a linear pair. S is angle A and angle B are adjacent and supplementary angles. Okay. We will go P, if and only if S. So I'm looking for A and B are a linear pair. A and B, not there. A and B are a linear pair. Okay. But it says if and then, right? So that one's not going to work. It's if and then. This one's not going to work because it's if and then, right? We're looking for if and only if. So it says A and B are a linear pair. If and only if A and B are adjacent and supplementary angles. It's got to be option D. Is that all right? Does that make sense to everybody?
Yeah.
This notation makes it very easy for us to create biconditionals if we kind of in the background just say these are the arbitrary hypotheses and conclusions that we could create. Okay, going through, this means let's go back to using P and Q. That means if P, then Q. Okay. Couple more here. This will be a test question at some point. This one says P, not Q. Okay, remember that tilde out front means not, so I reread that as if P, or rewrite it, then not Q. This one is if not P, then not Q, right? Okay, we can do this one. That's P if and only if Q. And then, I put Q in there. And this one would be like, we could put not on any part of P and Q here, or both of them. So what if I said something like this? That'd be not P, if and only if, not Q. Okay? So you've got to understand that notation because we want eventually to use that a little bit more than just the phrase. A lot of times they'll give you specifically a phrase to talk about, like any one of these that we did up top. Okay, they might give you this phrase here. Okay, and then later in a question, instead of having to rewrite that phrase completely, we'll just start talking about the hypothesis is P and the conclusion is Q, and you now have to make a reference back to it. Does that make sense? So we use that notation. It's very important to understand. Those are the questions I've seen people struggle with the most. And I think maybe one of the reasons was because of the idea of parallel. That means, so hopefully that exercise kind of opens your eyes to that. And then this notation. Okay. Do you guys have anything specifically you want to talk about for that assignment, that homework?
I was just
All the words.